As you can see on this page, there's many different types of numbers. You have square roots, fractions, repeating decimals, and non-repeating decimals. All of these numbers fall into two categories. The first category is rational numbers. Rational numbers contain fractions, whole numbers, repeating decimals, and terminating decimals for positive and negative numbers. The reason they are rational numbers is because they can be written as a ratio of two numbers. For example, 5 can be rewritten as a ratio of 5/1 or 5:1. The same thing would go for 2. Square root of 9 is really 3. Again, that can be written as 3:1. For our decimals, you have 9/10, so that can be rewritten as a fraction of 9/10. 73/100 would be the same thing. It can be rewritten as a fraction. 22/100 is going to be continuous repetition of 0.22222 repeating and so on for infinity amount of time. That still is a rational number. The next set of numbers are your irrational numbers. These are numbers that cannot be written in ratio form. Pi is the most common irrational number you will see. Pi is 3.14 and it continues on for thousands of digits. The square root of 7 is also irrational because it does not give you a whole number or a decimal that is repeating or terminating. The same goes for the square root of 5. 5/0 is also an irrational number because you can never have a fraction with a denominator of 0. If you look at the bottom, the 0.2022022 continues on in a pattern. Although it is a pattern, it is still an irrational number because it is not the same thing over and over again. If you were to have 0.202020 continuing on, that would give you a rational number. Estimating irrational numbers on a number line is easier if you can get that number between two perfect square numbers. For example, the square root of 8 is very close to the square root of 9, and the square root of 9 is 3, which means the square root of 8 is going to be between the numbers 2 and 3, but closer to 3. For B, the square root of 15 is very close to the square root of 16, which is 4. Therefore, the square root of 15 is going to be between the numbers of 3 and 4, but closer to 4. C, the square root of 12 is between the square root of 9 and the square root of 16. Well, the square root of 9 is 3 and the square root of 16 is 4. However, 12 is almost in the middle between 3 and 4. That is why if you look at the number line, I have placed dot C between 3 and 4, almost exactly in the middle. These are the examples that I gave you on the first page. What I would like you to do in your notes is to categorize these into rational and irrational numbers. I will be checking your notes tomorrow to see how you did. Tomorrow, your opening activity will be something similar to this.